Hello chaps and chapettes, welcome back to the classroom. We're going to be looking at time, which is quite possibly the weirdest thing in physics and the most misunderstood thing, well, by humans in general. So let's jump straight into it then, shall we? First of all, what you need to know about time is that you need to know that time is kind of like the measurement of change. You also need to understand how to use a clock to measure an interval of time, and this is going to be an analog or a digital clock. You also need to be able to take measurements from time using multiples, which sounds strange, but actually is rather straightforward. So we need to jump straight into what time actually is. And time can be thought of as the gap between where things move from place to place. As in, we have an object here, and then it moves to here. And it doesn't do that instantaneously. It takes a little bit of time to do so. So time is the rate of change from going from one place to another, or basically the measurement of how quickly something changes, or if it does change or not. It can get really difficult to understand what time is, and you get to a very philosophical state. You infer what time is, you kind of know what time is deep down, but if you try to put some words behind it, probably a bit more difficult than you might think. It also gets really strange because time's not as static as we think it is. It's actually quite malleable. For example, if you're high up in a tall building right now, time's actually moving a little bit slower for you than it is if you are at the bottom of the building. Turns out time changes depending on the gravitational field strength around you, which is just weird and baffling. So we're not going to get into that because you don't need to know that for GCSE physics. What you need to know is how to measure time. And to do that, you need a clock. And hopefully you know how to read a clock. If not, well, let me show you right now. Guys, before we go to the back of the classroom to play around with some different clocks, analog and digital, make sure you hit the like button so that the YouTube algorithm knows I'm here. All right, guys, join me in the back. Right. Right, now, this is an analog clock. And this is the only example I could find of one in my classroom, because we don't use stopwatches or analog versions of stopwatches. So there you go. You've got the ticking hand moving around the circle, and then you measure off on the numbers there. So hopefully you know how to use a clock. If you're not quite sure, well, go and research it now. I mean, it should be something that you need to know for every GCSE exam. But there you go, analog clock. Useful for telling the time if there's no other alternative. Right now, this is more like it. This is a digital clock. And you can see it's got a bunch of numbers on there. And this will be the display you get on most of your stop clocks. And it's quite simple in operation, where it says start and stop. That starts the clock and stops the clock. So you start it and stop it. And yes, I am trying to get it on 1 whole second. Let's try that again. And not even close. Wow, that's really close, but it's still not a whole second. There we go, got it, first time. So, the way we look at this one, this number here is going to be our seconds, and this number here is going to be our milliseconds, or at least the divisions of the second. So when you're doing your reading of this clock, this is going to be the usual business bit, and you can functionally ignore this one. This is just going to be there for your roundings, at least in most experiments. This bit here is going to be minutes, and whilst you might use this for some experiments, like long-term cooling experiments, you're really going to be sticking with the second part for most of your experiments. Now be careful, a lot of times you will have to convert back from minutes to seconds, and that's going to be a quick case of taking a minute number, timesing it by 60. So let's just do a quick example of that now. Okay, so I've got a pen ready, just need to make sure this is on some sort of minute reading. So let's go, and just go for a bit, so we get to 1 minute. I wonder if we can stop it on a whole second again. 5, 4, 3, 2, 1. Oh, that's quite close. Perfect, there we go. So we've got 1 minute here and 1 second. So let's just go through this. 1 minute, 1 second. There we go. So that's going to equal 60 seconds. And that's going to be, what, 1 second. So our total time, 60 plus 1, and I hope there's no space, 61 seconds. You may need to do that conversion at some point during a test, so just be aware it's there. One word about rounding though. Okay, so here we go. Oh my god, I can't believe we just did that. But I have to do it anyway, so here we go. 10138. This, of course, is going to have to round down. So we would list this as basically to 101. If we go a bit higher, you see it's gone past 57. So this would be, obvious, this would be 10157. We've got this above 5, so that would, of course, would round up. So that would be 102. So 61 seconds, 62 seconds. Okay. All right, so there we go. Right, we go back to the front of the classroom and explain some other things. Oh, one more thing. Reset button. There we go. Okay, so no surprises there. You kind of knew how to use a stopwatch already. They're not that difficult. So what we need to now know is how you can measure really, really small gaps of time. Because it's not as easy as you might think. I mean, if your reaction times are slow, you will not be able to turn the stopwatch off and on again quickly enough to actually measure something that's going fast, or really, really small distances. So what we need to do is use this idea of multiples. And for that, we're going to go right to the back of my classroom, and we're going to see the pendulum swinging back and forth. And I'll show you how you can use multiples to work out really short gaps of time from using longer gaps of time. So without further ado, guys, hit the like button, join me at the back of the classroom. Right, now we're at the back of the classroom with my very, very untidy classroom. There we go. Oh dear. There we go. So we're back at the classroom, at the back of the classroom with a very untidy classroom to look at this pendulum here. And what we're going to do is we're going to oscillate this. So like so. And we can see that the pendulum's going back and forth. Now, this is actually very difficult to measure, as in, well, what's the time period for this thing? First of all, we need to know what time period is. Time period is the time it takes to go from one end and back to the start. So, 1, 2, 3, 4, and so on and so forth, okay? Now we've got a problem, because if we tried to measure the time of this using a standard stopwatch, it would be quite difficult. So let's just try to do that. We're going to start at the top there, and let it go. Okay, and we're going to start this when it reaches its maximum point there. Now 2.63 seconds, not bad. Let's see if we can get it the same twice. So ready, and up. Yeah, you see there's a difference there, right? Now, what we need to do is take an average of all, 263, not bad. Take an average of all these different time measurements, but that would be quite difficult, and we need to do quite a bit of maths afterwards. So instead what we do is we count the number of swings to be, so we count 10 swings, and then we time that number, and then we divide that by 10, that gives us an average straight away. I'll give you an example of that now. So let's get this swinging again. So here it goes. Okay, and go. 1, 2, we're going up to 10 swings because it's a nice round number, 3, but you could use any number you like already, 4. 5 swings would be fine, 5, and 6. And what we're looking to do here, 7, is get a nice big number, 8, 9, 10. So that gives us 26.9 seconds. And what we would do is we take that number, we divide it by 10, and that would give us our time period for one oscillation. Not only that, but it gives us an average of it straight away. It's basically the average of 10 of the swings. And that's a quick, short hack of how to get an average number without having to do a lot of maths, a lot of calculations. So I'm just going to show you the actual sort of equation for that now. Right, so what we've got is the stop clock from before, and we know that that's 10 swings. So we can say that this has been 26 point, let's just make it a bit easier there, 26.9 seconds for 10 swings. Let's just move it over here a bit. There we go, for 10 swings. Now we want to find out what it is for one swing. Okay, and that would give us an average of all the different times that could be. Now the reason for that is because, okay, maybe it swings a little bit faster on one, maybe it swings a little bit slower, maybe there's some air currents and things getting involved in there. But we just want to avoid that whole sort of messy issue. So what we do is we just say it is averaged out over the course of lots of different swings. Okay, so here we go, 26.9. And we have to divide that by 10 because 10 swings. And that's going to be 2.69 seconds for one swing, which we could then round up to being 2.7 seconds or just 3 seconds. It depends on how many significant figures you've got. But that's the idea. So there you go. All right, so there we go. That measurement trick where you measure multiples of things and divide by the number of times you either swing something or it goes around or a number of instances there, it actually occurs quite a lot in alternative practical papers or any kind of practical exercise or experiment you do. So make sure you learn it, make sure it just becomes one of those little tools, mental tools that you have, which you can whip out whenever you need to. So you should know from the end of this video is that time is a measurement of change, roughly speaking. You should also understand how to use a clock to measure an interval of time. And you should also be able to take measurements of time from using multiples. So make sure that you have subscribed to this channel if you haven't done so already, so that you can find out your help when you need it, when you're doing your homework, when you're doing a test revision, or when you're studying for a very important event. And make sure you hit the notification bell so that you can get the latest updates in physics and exam results and all that kind of stuff. All right, guys, I'll catch you in the next video.